Fundamentals of deformable bodies is concerned with applied forces and their internal effects on bodies. One of these effects is shape change or deformation. The amount of deformation of an object will undergo depending on its size, material properties, and the magnitude and duration of applied forces. According to Ferdinand Beer, Russell Johnston Jr., and John D. Wolfe from the book 4th edition in International System Unit Mechanics of Materials, the main objective of the study of the mechanics of materials is to provide the future engineers with the means of analyzing and designing various machines and load-bearing structures. Both the analysis and the design of a given structure involve in determination of stresses and deformations. But what was stress? Stress is a physical quantity that expresses the internal forces that neighboring particles of continuous materials exert on each other. We are going to answer a problem which involves a normal and shearing stress. But what is normal stress? Normal stress is a stress that occurs when a member is loaded by an axial force. The value of the normal force for any prismatic section is simply the force divided by the cross-sectional area. A normal stress will occur when a member is placed in a tension compression. And on the other hand, shearing stress is a type of stress that acts coplanar with the cross-section of material. Shear stress arises due to shear forces. They are the pair of forces acting on opposite sides of the body. Here is an example. For the given state of stress, determine the normal and shearing stresses after the element shown has been rotated at 12 degrees clockwise and 10 degrees counterclockwise.
So in the first problem, an element has a given stress and we should determine the normal and shearing stress after the element is rotated in 25 degrees clockwise. Now, we are going to get the given in the problem. We have sigma x is equal to negative 60 megapascal, sigma y is equal to 90 megapascal, and the tau xy is equal to 30 megapascal. Our formula to be used when we need to get the shearing and normal stresses is we get the normal stress of along x-axis is equal to sigma x prime is equal to sigma x plus sigma y over 2 plus sigma x minus sigma y over 2 cosine 2 theta plus tau xy sine 2 theta. Along the y-axis is sigma y prime is equal to sigma x plus sigma y over 2 minus sigma x minus sigma y over 2 cosine 2 theta minus tau xy sine 2 theta. And to get the shear stress, we have T x prime y prime is equal to negative sigma x minus sigma y over 2 sine 2 theta plus tau xy cos 2 theta. When we get the average of the given sigmas, we have sigma x plus sigma y over 2 is equal to negative 60 plus 90 over 2. We have our average of 15 megapascal. And now we get the sigma x minus sigma y over 2. We have negative 75 megapascal. So in the problem, we have our theta 25 degrees. So in the first problem, we have our theta 25 degrees clockwise. When the problem is clockwise, our theta would become negative. So we have negative 25 degrees Celsius. But since in the formula, we have 2 theta, negative 25 times 2 is equals to negative 50 degrees. So, So now we are just going to plug in all our values. So we have negative 25 times 2 is equal to negative 50 degrees. So now we are just going to plug in all our values. So we have negative 25 times 2 is equals to negative 50 degrees. So now we are just going to plug in all our values. So we have negative 25 times 2 is equals to negative 50 degrees. So now we are just going to plug in all our values. So we have negative 25 times 2 is equals to negative 50 degrees. So now we are just going to plug in all our values. So we have negative 25 times 2 is equals to negative 50 degrees. So now we are just going to plug in all our values. So we have negative 25 times 2 is equals to negative 50 degrees. So now we are just going to plug in all our values. So we have negative 25 times 2 is equals to negative 50 degrees. So now we are just going to plug in all our values. So we have negative 25 times 2 is equals to negative 50 degrees. So now we are just going to plug in all our values. So we have negative 25 times 2 is answers and givens. We have sigma x prime is equal to sigma x plus sigma y over 2 plus sigma x minus sigma y over 2 cosine 2 theta plus tau xy sine 2 theta. Now the average is 15 and we are going to add it by negative 75 cosine negative 50 degrees plus 30 sine negative 50 degrees, which will give us negative 56.2 megapascal. And in sigma y prime, we have the average of sigma x and y minus sigma x minus sigma y over 2 cosine 2 theta minus tx sine 2 theta. We have the average of 15 megapascal minus negative 75 cosine negative 50 degrees minus 30 sine negative 50, which will give us 86.2 megapascal. And now the shear stress along 25 degrees clockwise angle along 25 degrees. So our shear stress would be negative sigma x minus sigma y over 2 sine 2 theta plus txy cosine 2 theta. So we have minus negative 75 sine negative 50 degrees plus the 30 cosine negative 50, which will give us negative 38 megapascal. In the second problem, we have theta is equal to 10 degrees counterclockwise. Since we have counterclockwise, our sign would be the same, would be positive. When we have 10 degrees, it would always become 10 degrees, but since we have 2 theta, so we multiply it by 2, so now we have 20 degrees. And repeat the process. Sigma xy is equal to 15 plus negative 75 cosine 20 plus 30 sine 20. We have the normal stress along x-axis. We have negative 45.2 megapascal, and in normal stress along y-axis, we have the average 15 minus negative 75 cosine 20 minus 30 sine 20. We have the normal stress along y-axis is equal to 75.2 megapascal, and the shear stress would be minus negative 75 sine 20 plus 30 cosine 20 would be 53.8 megapascal, which gives us our shear stress of 53.8 megapascal.